So we'll start with our IoT class. So we are in second chapter. What is second chapter name? Yes. Can anyone tell what is the second chapter name?
Domain specific IoT.
It is domain specific IoT. Okay. So what will happen? What you are learning is different applications. So far, what all we have learned? How many applications we have seen of IoT? One is in home automation. Second was how to make your city smarter, and third one was for your environment. Okay. So today I'll show you one image. Okay. So you should tell me today application of what I am teaching. Okay. So today IoT application of what I'm teaching, you guess, because daily I'll start with that today I'll be going to teach this. Yes. So which applications you'll be learning? Can you tell seeing this image? Yes. So you'll be learning what today? Seeing the image, I have given you a clue. Seeing the image, can you tell? Yes. No one. You people have connected and gone, or you are there?
Forest fire detection.
Yes. What?
Forest fire detection.
Forest fire detection we have completed, no, yesterday. This image, can you see the image on the other? Seeing this image, can you guess the topic?
Energy.
Yeah, it's energy. Okay, then what is energy? So today you will be studying about IoT applications in energy. Then what is this energy? Many times you might be hearing about energy. Okay, you might also have some energy, right? Yes or no? Do you have energy? And how you get energy? You also have energy within yourself, right? So how you will get the energy? You will eat the food, okay? You will do some physical activity. Yes or no? Whenever you do some physical activity, okay? So energy is created within you. Yes or no? When energy is created, when some work is done, so you have to be doing some work. If you don't do work, there will be no energy. So then today we are not speaking about your body energy, but we will be speaking about electrical energy or some energy through which we can run the system. Okay. You had studied in schools, right? There are two types of energy. One is potential energy, one other is electrical energy. Yes. So don't get scared. I'll not be teaching you potential energy or kinetic energy. Okay. So we'll be seeing how IoT can be used to make your energy system smarter. So which energy system you're using in your home? Yes. Are you using any energy? Not your
Electrical energy.
Yes, you're using electrical energy. Yes. Some people might be using solar energy. Okay. Some villages they will have that wind thing. Why that wind fans will be there? Wind turbines will be circulating, no, in some villages. Why it is used? Now it is less. Now people are using most of where electricity is not there, they will use solar energy, and earlier wind energy was used. Yes. And mostly what we use is electrical energy. Okay. So in this, can you tell me how we can use IoT? Yes. Why we need IoT in this electricity and all? Water is there, it will generate, right? Yes. So if you take existing grid, okay, I'll show you existing grid. What you can see on the screen? Still you are able to see bulb, or this grid you can see? What are you able to see in the screen? Not able to see.
Grid ma'am.
Okay, you are able to see grid, right? So this is your existing electrical grid. Okay. So what is electrical grid? You know, right? That is, there will be some power station. What power station will do? They'll generate the power, then it will go to transformer, it will go to the grid, then transmission lines will be there, substation, power lines, through many various substation and all things, the electricity will come to homes and commercial facility. Yes or no? So through this, it comes. Okay. So this is existing grid. You need not study about this. I'm just giving you an idea because some people will be not knowing how the electric energy is coming to your existing, that is to your homes. Okay, this is the existing system. Now, can anyone tell how to make it smarter? Yes. Can anyone tell how to make the existing grid smarter, where all it can be used? IoT, where we can use? This is your current scenario of the electrical grid. Yes. Any idea how to make it smarter? Yes. How to make it smarter? You people are just connected and sleeping or having breakfast. You people have got up, right? Yes. How to make it smarter? Any idea? This is the existing electric grid. So just I'll show you a video. At least after that, you try to tell me. Okay. What you can see on the screen? Can you see a video on the screen?
Yes, ma'am.
Yes, ma'am.
Yes or no? Can you see a video on the screen?
Yes, ma'am.
Okay, can you hear that?
100 years ago.
See, can you hear?
Yes, ma'am.
Okay, fine. So you just watch this video and then tell me how we can make your existing electric grid smarter. Okay. So it will tell you, this video will tell you what is smart grid. So listen to it carefully. Any disturbance, you can interrupt and tell me.
When electricity needs were simple. Power generation was localized and built around communities. Most homes had only small energy demands, such as a few light bulbs and a radio. The grid was designed for utilities to deliver electricity to consumers' homes and then bill them once a month. This limited one-way interaction makes it difficult for the grid to respond to the ever-changing and rising energy demands of the 21st century. The smart grid introduces a two-way dialogue where electricity and information can be exchanged between the utility and its customers. It's a developing network of communications, controls, computers, automation, and new technologies and tools working together to make the grid more efficient, more reliable, more secure, and greener. The smart grid enables newer technologies to be integrated, such as wind and solar energy production and plug-in electric vehicle charging. With our participation as informed consumers, the smart grid will replace the aging infrastructure of today's grid, and utilities can better communicate with us to help manage our electricity needs. The smart home communicates with the grid and enables consumers to manage their electricity usage. By measuring a home's electricity consumption more frequently through a smart meter, utilities can provide their customer with much better information to manage their electricity bills. Inside the smart home, a home area network, or HON, connects smart appliances, thermostats, and other electric devices to an energy management system. Smart appliances and devices will adjust their run schedule to reduce electricity demand on the grid at critical times and lower consumers' energy bills. These smart devices can be controlled and scheduled over the web or even a TV. Renewable resources, such as wind and solar, are a sustainable and growing source for electric power. However, renewable power sources are variable by nature and add complexity to normal grid operations. The smart grid provides the data and automation needed to enable solar panels and wind farms to put energy onto the grid and optimize its use. To keep up with constantly changing energy demands, utilities must turn power plants on and off depending on the amount of power needed at certain times of the day. The cost to deliver power depends on the time of day it is used. Electricity is more costly to deliver at peak times because additional, often less efficient power plants must be run to meet the higher demand. The smart grid will enable utilities to manage and moderate electricity usage with the cooperation of their customers, especially during peak demand times. As a result, utilities will be able to reduce their operating costs. By deferring electricity usage away from peak hours and having appliances and devices run at other times, Electricity production is more evenly distributed throughout the day. The power being used right now was generated less than a second ago, many miles away. At each instance, the amount of electricity generated must equal the consumption across the entire grid. Smart grid technologies provide detailed information that enables grid operators to see and manage electricity consumption in real time. This greater insight and control reduces outages and lowers the need for peak power. In control rooms across the grid, engineers will be able to more precisely and predictably manage electricity production, reducing the need to fire up costly secondary power plants. The distribution system routes power from the utility to residential and commercial customers through power lines, switches, and transformers. Utilities typically rely on complex power distribution schemes and manual switching to keep power flowing to their customers. Any break in this system caused by storms, bad weather, or sudden changes in electricity demand can lead to outages. The smart grid's distribution intelligence counters these energy fluctuations and outages by automatically identifying problems, then rerouting and restoring power delivery. Utilities can further use distribution intelligence to predict and manage electricity usage with the cooperation of their customers, leading to lower production costs. The charging of a plug-in electric vehicle can be managed over a home area network, or HON. The HON can balance the demand for electricity across the household and prioritize between the electric vehicle and other appliances to manage electricity usage and reduce costs. With smart grid technologies and consumer participation, utilities can more easily handle the increased demand for power to run the electric vehicles and ensure charging needs are met. By adding more plug-in electric vehicles to the grid, we have the potential to reduce fuel costs, lower our dependency on foreign oil, and help reduce greenhouse gas emissions.
Yes. So you could see the video clearly. If you could not see the video clearly because of internet issue, this video is there in Google Classroom also. Now seeing this, can you tell me how smart grid helps? Yes, existing grid is mechanical. Okay. Now what we are doing, we are bringing.
Welcome to everyone. I'm James Jensen, today's webinar chair.
Sorry, one second.
I'm a contractor supporting the Office of Indian Energy Policy and Program Tribal Energy Webinar Series. Today's webinar type.
Okay. So what is happening in existing thing? It is mechanical. Okay. Existing network is mechanical, and there are some problems with the existing electric grid. Can you tell me? You saw a video, right? What is the problem with the existing grid? Yes. What is the problem with the existing grid? You people could see the video, right? Yes or no? 30 people are there. What was the problem with the existing grid? Yes. So one Kishan told that it was only one way. Okay, one way interaction. Lot of losses were happening. Okay, in the electric grid, lot of losses will happen because anywhere wire will break or wire leakage is happening, we will not come to know. Yes. So we will not come to know what is happening and all. Okay, where is the leakage, why the electricity is getting wasted, and also what is happening in existing grid. We cannot add this solar energy also is lot, no, in India. So we cannot generate this electricity generated by solar, we cannot send it to same grid, or wind energy we cannot send it to same grid. If we have smart grid, we can use electricity generated by water in the same grid, by wind in the same grid, as well as solar in the same grid. Plus what will happen in smart grid, we have Wi-Fi. Okay, your actual computer network will come in smart grid. So when it will come, what will happen? It will help the customer to reduce their electricity bill also. They'll come to know where they're using which appliance, everything. It will, if it is smarter, no, everything it will track, which bulb, which tube light, or which light, which geyser, how much, when it is, why your electricity bill is coming this much. So all those things can be tracked even for the electricity people, it is helpful, because where is the leakage and all, it will be help. And if any problem, see now these days any electricity will go because of some transformer burnt or anything burnt, will very difficult. We should call the person, he should manually go around and find out what is the problem, then correct the electricity. Sometimes it happens, right? Only in your house correct electricity will be not there, in everyone's house electricity will be there. That time how much you struggle to get back. Yes. So if you use IoT system, if your electric grid is smarter, you will never face such problem, and also cost of the electricity bill will be less. So we will see the some of the points. Okay. What you can see on the screen, can you see the PPT? What you are able to see the on the screen?
PPT.
Okay, PPT you are able to see, right? So we'll be discussing about, that is your fourth application, that is IoT application in energy. Okay, so in this you will be studying three things, that is smart grid, renewable energy system, and prognostics. Okay, all related to energy only. So just now we saw a video how to make your grid smarter. Next we will see, if we use the smarter grid, or if we use IoT, we can also use same grid for renewable energy system. Which are renewable energy system? Yes, non-renewable, renewable energy system you have studied, no? Which are those? Your wind energy, your solar energy. Okay, how to use the same electricity grid to get the energy from wind, solar, that you will be studying in. And third is prognostics. What is the English meaning of prognostic? Can anyone tell? Yes, what is the English meaning of prognostic? Yes, prognostic means before some problem occurs, we will try to identify. Why we have to try to identify before problem occurs, and where problem will occur in electric grid or any grid? You will be using small components, right? Yes or no? You will everything, even your grid is smart, some mechanical components will be there. So you have to identify which component is going to fail, or maybe your meters are going to fail. If meter is failing, electricity people cannot charge you appropriately. Okay, all those things you will be studying. So these are the three applications under energy you will be studying. One is smart grid, second is renewable energy system, third is prognostic. Okay, so what are smart grid? It is, see, your existing electric grid is a mechanical grid. Okay, whereas smart grid is your data communication network integrated with electric grid. Okay, so now here, instead of having only electric grid, we will have a data communication network. What is data communication network? You remember something about CN? Yes, what is data communication network? Yes, what is data communication network? Your computer network it is. Okay, where any network you can make social network with the people, or any other network with mechanical components. But in smart grid we will use data communication network, because data will flow. Why it is called data communication network? Because if you use computer network, what is the main thing that flows? Data communication network, and it will be integrated with electrical grid. And what that data communication network will do, it will collect and analyze data captured in near real time about power transmission, distribution, and consumption. Okay, so your this network, data communication network, which is integrated in your electric grid, what it will do, it will tell you, it will analyze and collect the data about how much power is transmitted, distributed, or consumed. Okay, and it will also provides the predictive information and recommendation to utilities, their suppliers, and their customers. That is, it will tell you how best you can manage the power. Right now you don't know, right, how much your fan takes, your bulb takes, or which, how to reduce the electricity bill, you will come to know, because it will track each device and it will tell you this device at this time this much it has utilized, so your bill this much. Okay, next, third one is smart grid collects data regarding Again, it is same. That is electricity, generation, consumption, storage, distribution, and equipment, health, data. And one more thing, Kishan told, right? Smart grids are high-speed, fully integrated, and two-way communication network. Okay, it helps in two-way communication. Okay, that is for real-time information and power exchange. Your existing network is one way. Okay, whereas smart grid will be two-way. Okay, if existing grid will be two-way, what will happen? Yes, electricity will be coming from the grid, again you will send, it will become something else. But so on this smart grid are two-way. Okay, so next, by using IoT, what we can do, existing grid we can make it as smart grid. Okay, and again whenever IoT will come, sensors will come. Okay, which will collect the data. Okay, and also it will not only collect the data and help you to save the electricity, but also it will help you to see the health of equipments. What is health of equipments? Components you'll be using to get the electricity. So it will tell you before only, either from grid to your home some component is going to fail, or in your home only some electricity component is going to fail. It will tell you everything. And also if you have smart grid, your electricity meters you have seen, right? How are your electricity meters right now? Okay, they're not smarter, but if you use smart grid you will have smart electricity meters. Okay, so it will have everything, it will just record properly based on each device how much it is consuming the electricity. Plus if someone is trying to rob it, that also can, or if someone is, maybe sometimes some people will try to take electricity from your connection, right? Such things also you can identify. Otherwise what will happen, will not come to know only. If via our electricity connection, if someone is robbing and taking electricity to their home, we will not come to know. If we have smart meter, it will track that also. Okay, and third one is by analyzing the data on power generation, transmission, and consumption, smart grid can improve efficiency throughout the electric system. We can improve the electric system. Okay, if we use this smart grid. And also if you storage collection and analysis of smart grid data, what you collect will be stored in the cloud based system. That is, we'll be storing it in cloud, and this will improve in the energy usage level. Okay, any doubts you have in smart grid? If no, we'll go to next one. What is next application? Can anyone tell? Okay, what is next application? Smart grid is over. 3 application I told. I'll tell you in energy. One is smart grid. Second one was renewable energy. Renewable energy. And third one is prognostics. So we'll see next renewable energy. What is renewable energy? Yes, there are energies which are like from solar or wind. Okay, so if we have an existing electrical grid, okay, in that we cannot send, see now what we are getting, solar energy and wind energy, that we cannot send through the same line. But if you use smart grid, we can send it through the same line. Okay, and see what was happening in existing grid. Yes, existing grid were designed to handle power flows from centralized generation source to the loads through the transmission and distribution lines. So it is not two-way, it is one way. But your renewable energy is a two-way. Why? Can you tell me why renewable energy is two-way and why existing electricity is one way? Yes. And why renewable energy needs to be bi-directional? Why it cannot be single directional? Yes. Now, how you are getting electricity? From the grid, it will go to your homes. From your homes, is it going to grid? Is it going to grid from your homes? No, right?
No, ma'am.
No. But why renewable energy has to be bi-directional? Yes. Anyone has fields with solar panels and this wind this turbines? If yes, you will get the answer. See what is happening now. Some field people, okay, now government is giving so many subsidies, okay, that is if you have to put the solar panels. Now lot of heat is there, right? In India, a lot of sun is there, so they are giving some subsidy to put solar panel. So using solar panel, what you can do, what you can generate, you can generate some electricity, that is some solar energy you can generate. So that much energy will be not required for them only, right? You anyone has solar panels? If you put a small solar panel, maybe it is sufficient for your heating your water in home or something. If you will put many solar panel, what will happen? You will produce lot of energy. Yes, that much it will be more than what you want for your homes. That time what will happen? So instead of making wasting the energy, you can sell it to the electricity people. Okay. So from your homes, extra energy, what you don't require, what you have generated, you can sell it to the grid. Okay. So we need bi-directional when we use renewable energy source, because only now we have centralized people who will power those people only will generate the power and we will get. But in renewable energy, what you can do? Everyone can generate the power. Yes or no? Solar panels you have seen? Yes. So that is the thing. If you have existing grid, that is single direction. You cannot produce your electricity and send it. When if you are taking it from someone, what will happen? Sorry, if you are only generating, it needs two-way. Okay. So they are telling that distributed renewable energy source are integrated into the grid. Okay, they create power bi-directional, okay, powers, but your existing grids are not originally designed for bi-directional. Okay, so if you use smart grids, it will be bi-directional. Okay, any doubts you have in this 3 points? Renewable energy is nothing but energy generated by solar and wind. Okay, existing grids are single directional, but for renewable energy we need bi-directional. Okay, and if you use IoT, what will happen? Okay, IoT based system can be integrated with transformer at the point of interconnection measure. Okay, that measure the electrical variable and how much power is fed into grid, and also it will help you in grid stability. Okay, and for wind energy, closed loop controls can be used to regulate the voltage at point. Actually, existing grid voltage fluctuation will be more. To avoid that, we can use IoT system. So this is your second application. And the third application is prognostic. Yes. So third is prognostics. So I told you what is prognostic. What is prognostic? Can anyone tell? Yes. What is prognostic? Just now I told you.
We can know before only.
Predicting
Yes.
about failures.
Any failures we are going to predict before only. Why we have to predict failures in the grid? Yes. Why we have to predict? Yes. Because your grid will have small components, right? Like maybe you're using wind energy, also wind turbines will be there, or some electric components will be there, various mechanical components will be there. Yes or no? So we have to do prognostics. Currently, are they doing prognostic? If anything fails, what they'll do? If anything fails, one lineman will be there, all the places he'll roam, he'll try to connect some wires, he'll do trial and error, then he will try to correct your electricity supply. Yes or no? But if everything is automated, what will happen? Everywhere that software will be there, your network will be there, your internet will be there. What they'll be doing? All the time, there will be sensors will be there, they'll be monitoring what's where, which component is about to fail. When it will monitor, again internet also, Wi-Fi is very important, because this sensor data has to be sent somewhere, right? Yes or no? Sensor only will see go on recording data, no use. It has to send it to some database. From database, application will take, okay, it will process, and it will now intelligent systems are coming, they'll only process and give the alert to the concerned authority, this is going to fail. then he can send someone and replace the component. Okay, so energy system, smart grid, power plants, wind turbine farms, for instance, have a large number of critical components. Okay, so it should function correctly so that system can perform their operation correctly. Okay, that is, for example, turning gears, bearing, many components will be there, right? Yes, so if in the system so you can use in the systems like such as power grid, real time information is collected using specialized electrical sensor. Okay, which electrical sensor we use here? Phase measurement unit, PMU. Okay, at the substation. So quickly I'll finish because it will end. Again, rejoin, okay, if it will end the meeting. Okay, the information received from this sensor has to be monitored. Okay, then only we can predict the failure. Okay, we can estimate the state of the system, predict the failure. Okay, and also what we can do is that's what doing this prognostic, main thing what we can do, we can predict the performance of machine or energy system. Okay, how it will do? Any IoT system and some sensors will be installed that will be sending the data, and internet is required. Otherwise, where sensor has to send the data, it will not have lot of storage. Sensor can only record the data. It has to send through the network the data to the database. The database can be anywhere, either there only. You cannot keep the sensor in all the electric grid. We have to place it somewhere, and then there will be application. Okay, this is the image given in your textbook. Okay, there is a smart grid. Renewable energy also is integrated here, and also we are using prognostic health management to see any system is going to fail or any component is going to fail. So if a meeting will disconnect, again rejoin. Okay, so we will see some of the quiz questions. So some of the questions are there. That is, dash is the data communication network. What is the data communication network? It is your smart grid. Smart grid uses dash two-way communication. Which is that? Which is the answer? That is high speed, fully integrated two-way communicating system. For wind energy, okay, dash can be used to regulate the voltage. Which one? Can you see the question? How to regulate the energy? Yes. So questions are there. I'll not tell you, go through it. Okay. In Google Classroom, the questions are okay. So I'll just tell you important questions. Okay, what all we have discussed today. So one question for 10 marks is there. See, explain application of IoT for energy system. So which all you will write? Yes, which all you will write? Yes. You people can hear me, right?
Smart grid, prognostic.
Yeah, you will write. What is that? About smart grid you will write. Okay, prognostic, and also about renewable energy system. So any doubts you have? 10 marks question is there. Okay, write all the this, what is that? Your assignments, anything you're writing, write point format. Okay, today also I'll this release one more assignment. Okay, so you can do that also. Any other doubts?